So we would need, so in your cooling system in your car, there is a fluid, and that fluid could be water, but usually they mix the water with antifreeze to prevent your cooling system from boiling over or from freezing up. And I actually had experience with this when I moved from our temperate region in California to Colorado, because I remember my old car had a leaky radiator, so I figured antifreeze was going up in price from it went from like $1 a gallon to $5 a gallon. So I figured I'm just gonna put water in there. And of course, as soon as the winter came, I hadn't lived in a place where it snowed before. It snowed, and I'm driving to work, and all of a sudden my car is overheating. I said, God, it's like 20 degrees out. My car is overheating. I said, oh shoot, I got just water in my. I got water in my radiator, and of course the water froze, and therefore I didn't have any liquid in my cooling system, and my car was overheating. So I pulled over the side of the road, and luckily there was a bus there, so I took the bus to work. I came back and opened up my radiator cap, and there I had a frozen block of ice in my radiator. So I figured that's why I gotta have coolant in there rather than just water. So that was my experience with understanding how antifreeze really works.
Did you just have to tow it? Or?
No, actually, I had some. There was a car parts store down the street, so I trudged over there in the snow and got some antifreeze and mixed up a 50-50 mixture and put it in the radiator and waited for a few minutes and turned the key in my ignition and worked. So when you're a student, you figure you got to figure out ways. But I didn't want to call a tow truck and take the shop unless I actually had to. Okay. So anyway, Prestone coolant contains ethylene glycol. So ethylene glycol is an alcohol. So it's a 2-carbon alcohol that has 2 alcohol functional groups. The molar mass is 62 grams per mole. The density is 1.11 grams per milliliter. The melting point is actually pretty low, minus 16 degrees. But note the boiling point is much higher than that of water. Water has a boiling point of 100 degrees. Ethylene glycol has a boiling point of 197 degrees. Now the antifreeze or coolant function is not only to cool your engine, but also for freeze protection. It also has to inhibit corrosion and inhibit scale formation. What's scale? We have a lot of scale formation in Salinas because our water is very hard. So scale is actually lime. Okay, so you see those white deposits on your faucets or in your bathtub. That's actually from lime. Or on maybe your pots and pans or dishes or cups or glass. That's actually from lime. Okay, so anyway, this is supposed to inhibit scale formation. Now on the Prestone label, it says if you have a 50-50 mixture of Prestone and water, that's supposed to protect your engine to 265 degrees Fahrenheit. If you have a 70-30 Prestone water mixture, that's supposed to protect your engine up to 276 degrees Fahrenheit. So based on this information, which substance, the ethylene glycol or the water, is the solvent?
Water.
Okay, so let's do, how do we approach this, answering this question? Okay, so you have a 50-50 mixture, and then the temperature they say is, let's see, 265 degrees. You have a 70-30 mixture, and it's 276 degrees. Okay, so how are we going to approach this problem? There's a couple ways to do it. Maybe more than a few ways to do it. Okay, so we know that for water, what's the boiling point of water? It's what's the boiling point of water?
Oh, 212.
Yeah, this is 212 or 100 degrees Celsius. If we look at ethylene glycol, let's see, ethylene glycol has a boiling point of 197 degrees Celsius. What's the, in degrees Fahrenheit, what's the boiling point of ethylene glycol? Do you have a conversion thing in your calculator? Okay, so for that. Okay, so the conversion is this one. If you have, let's say, for degrees Fahrenheit, it's degrees Celsius times 9/5 plus 32. I think that's it. So what's the boiling point of ethylene glycol in degrees Fahrenheit? Okay, so we have 197 times 9/5 plus 32. So based on this information on the chalkboard, can you determine which substance is a solvent, water or ethylene glycol? In that 50-50 mixture or 70-30 mixture of Prestone and water.
What do you need to know to identify that? That's where I'm starting. What properties do you need to know about those solvents?
Yeah, well, that's a good question, but these are the properties we're going to look at: boiling point elevation and freezing point depression. Now, we said that if you add a solute to a solvent, the boiling point of that solution is going to be elevated. Okay? So, here's one thing you can do. Let's assume that ethylene glycol is a solvent. So if you add a solute to ethylene glycol, what should happen to the boiling point of the resulting solution? Is it going to be greater than 386 or less than 386? It should be greater. Let's assume that water is a solvent. You add a solute to the water. Is the boiling point going to be greater than 212 or less than 212? Greater. So based on these two, on this information, can you determine which substance is going to be the solvent?
H2O.
And why is it H2O?
Because it's, the temperature increases. The boiling point goes up.
Because the temperature changes because you added ethylene glycol.
Well, it changes, yeah, but I think Joseph, can you repeat something?
But the boiling point goes up higher than 212?
Yeah, because look, if you consider water to be the solvent and ethylene glycol the solute, note that in each case, the boiling point of that solution is greater than the boiling point of the pure water. If you look at the ethylene glycol as a solvent, note that the boiling point of these two solutions is less than the boiling point of ethylene glycol. So based on this idea of boiling point elevation, water has to be the solvent in this Prestone water solution.
And I don't understand that. Like, what do you mean, like, when you add the ethylene glycol to the water, it changes it increases the boiling point?
Yeah.
So then why does that make the solvent go up?
Oh, because, see, note here, 386 is greater than 265. So if you consider ethylene glycol to be the solvent, and you add water to it, according to the boiling point elevation, the boiling point of the ethylene glycol water mixture should be greater than 386. But it's not, it's actually less. And the other thing too is if you actually do the calculation that we did, using delta TB equals I times KF times M, you get a pretty close, your boiling point of the 50-50 and 70-30 mixture using water as a solvent and ethylene glycol as a solid. It gets pretty close to these numbers. Okay. Now if you're more interested in coolants, note that I like this title, Coolant FAQ. This is from the JCNA Jaguar Clubs of North America. Coolants, better living through chemistry. And they give you a whole bunch of information about antifreeze and coolants. And actually, here's what they all say. So they actually do this comparison. A liquid must have specific properties to work as a coolant and antifreeze. So they look at boiling point, the vapor pressure, the specific heat of that liquid, the latent heat, which is the amount of heat required to boil, that is to go from the liquid state to the gas state. Surface tension, so we talked briefly about surface tension in Chem1A. That's the property of a liquid. That surface tension is the, one way to look at it, that's the ability of a liquid to stretch its surface when a force is applied to it. Okay, that's how we can look at surface tension. And then specific gravity is another name for density. Okay, so if you're more interested, you can take a look at this website. Now, colligative properties can also be used to measure molar mass. So here's a couple of problems from the textbooks. Here's one. Take a look on page 463, problem 13.84. Let's take a look at that one. And that problem states a forensic chemist is given a white powder for analysis. She dissolves 0.5 grams of the substance and 8 grams of benzene. The solution freezes at 3.9 degrees. Can the chemist conclude that the compound is cocaine, C17H21NO4? What assumptions are made in the analysis of this white powder? So on a TV show,